everyone. Thank you for tuning into my session today in more Serverless event. It's so great. I mean, so great to be here. I'm very happy. Thank you for inviting me. All right. Is it time to roll, Brian? All right. Okay. So let me go ahead. So today I will be sharing about developing stateful serverless workflows using Azure Durable Functions. And before I got started with that topic, I think Brian already presented me pretty well, but I'm Jonah Andersson. I'm based in Sweden, and these are the things and the stuff that I do. And I'm very passionate about what I do, both in my day-to-day job as a software engineer or DevOps engineer, and at the same time, the community job that, or not job, but contributions that I do as a Microsoft MVP and an Azure trainer, sharing knowledge to everyone. And I'm also currently writing my book about Azure, so feel free to check it out. So today I'm planning to go through a bit about serverless and Azure, Azure Functions, what it is, durable functions, the application patterns that you need to know to solve some complex workflow problems, and also an example use case and code snippet for each patterns and recommended learning resources. And before we go through that, I want to share with you about the dining philosophers problem. I'm not sure if you have encountered that before, but the first time I encountered this was when I was studying Java development. And this is a scenario where there are like 5 philosophers. They only have 5 chopsticks in the table and they need to eat dinners. And of course, if you're eating chopsticks or spoon and fork or knife and fork, you would need 2, of course. But if the problem that we have in this dining philosophers is that if both of them pick up the spoon or the chopstick from left to right, they're gonna have a problem. They're gonna have a problem, of course, for example, deadlock, because they won't be able to eat. And then, of course, they will get hungry and they will starve. So the point that I have here, why I'm sharing this problem, because when I was learning Java, I thought and concurrency, of course, as a programmer, I thought it was very interesting to have this example, because this happens as well in our normal lives. For example, in crossing in the roads, if you don't have control about concurrency in the traffic, we don't have traffic rules, then deadlock can happen there as well. And I also think as a developer, based on my experience for the past 8 years as a developer or an IT consultant working with both front end, back end, and cloud integrations, I noticed that one of the challenges that I have, or bugs that are hard to debug and fix, are concurrency problems or racing condition problems or deadlock issues between APIs and backend services and how it is talking to the client. And I believe myself that serverless solutions like Azure Functions, if you're working with the Azure Cloud platform, is a good solution for this. And to those that are new in serverless, I assume that there are some of you that haven't worked in serverless. So just to introduce you a bit about it. So serverless is actually a service or a technology where the servers and infrastructure are abstracted, and cloud providers like Microsoft Azure, GCP and AWS and other great cloud providers are taking care of that infrastructure for us so that we can focus on, like, for example, developer productivity and also delivering logic and functions to the business and have that flexibility and some seamless integration within the platform, and also other APIs that are external. And one benefit of serverless as well is that it has this consumption model, which means that you only pay for the instance of your serverless, or the pay as you go model when you're running those logic that you created. So since Sweden has this term Fika, so we have this. Fika is a tradition in Sweden where family, friends, and colleagues gather together to get something to eat or sweet to eat during a coffee break. And I want to compare serverless in this way. So this is what we have today, the infrastructure that we know. So we have the monolithic architecture, which is like layered cakes. You have everything in one place, the data layer, the logic, everything, business layer, it's in there. And then we also have the microservices that are like cupcakes. So they can be chocolate flavored, and that chocolate flavored, if translate it to software development or cloud development, it could be a microservice that handles user management or order management. And then we also have containers, like a box of cookies, where we have everything in one place. So that box of cookies can be deployed to a Linux operating system. It can be something that works for Windows or whatever that's on premise that needs to be in containers. And then serverless, they're light, they're easy to carry. If you need something sweet, then it's like candy. Like you can implement a function to send an email through a trigger using serverless. But the point that I'm showing this to you is not to make you hungry this morning, to those that are in the States right now, but also, or States or Canada or wherever you are. But it's about, my focus is the more you go to the left, that means you have more control, but that also means that you lose the productivity that you have for your software developers, your IT team. And the more we move to the right, which is what's going on in the trend these days, is to do containers and serverless, the more we gain productivity so that we can deliver to the business. And to start with the topic of today, before I move to durable functions, I want to introduce you to Azure Functions. So Azure Functions is a compute service in Azure where you can code event-driven, and then you can focus on logic. And basically, it's a code, your logic, and then you have the events that you have, which might be a trigger like an HTTP trigger, or it might be a trigger that was generated because you uploaded an image to a blob storage in the cloud, and of course the data that you're going to pass in through those logic. So, and then the next one, which is the highlight of today's session, is the durable functions. So durable functions is an extension of Azure Functions. So this means that all the capabilities of Azure Functions is in durable functions, but durable functions are more focused into it's designed for us to work effectively, or to work with stateful workflows in serverless environments. And one of the features of durable functions, because it's stateful, is that it manages and checkpoints and restart the state for us, which is not common in a standard Azure Functions. So the technology behind it, it's because of the Durable Task Framework, which is an open source repo that you can check on the link through GitHub right now in that link. So the languages supported are actually the common languages that we have today: C#, JavaScript, F#, PowerShell, and recently they also have supported Java for durable functions. So these are the programming languages. So since I'm a .NET developer, but since we want to learn what we can do with durable functions. So these are the languages. So if you're, for example, if you're coding, you're good in doing JavaScript, it doesn't stop you for coding durable functions. There's a tool or support for that, SDK for this tool. And then when you're working with durable functions, it is important to know the concept of the different types. So there are actually 4 types that's documented. So there's the client functions, which is actually the type of functions that can be it is like a starting point of your orchestration. This can be your HTTP trigger or a Cosmos DB trigger. And there are actually different types of triggers available, and there's a list of them. But the point of client functions is that it kickstarts the orchestrator functions, or the orchestrator. It starts the orchestrator. So, and the orchestrator is where you write your workflow, depending on the type of pattern or things that you need to do for your activities. So the activity functions are the basic unit of work or the task that you need to do. Like, for example, send email or get this data from the database, or it can be anything else, a specific task that you want to do based on how you authored your workflow. And there's also entity functions, which is used commonly for .NET. There's what they call durable entities, which is it helps in coordinating the status or the state of a class. For example, if you're working with context with a database, so you can use entity functions for that as well. And the orchestrator actually is like the Philippine national folk dance. We call it in the Philippines, since I'm Filipina also, we call it tinikling, which is a traditional Philippine folk dance. So the orchestrator, just like in any stateful workflows, it is important that all activities in your workflows are designed in good coordinations. Otherwise, there's a possibility that your workflow won't work properly, just like this tinikling dance. So if this girl and the boy are not coordinated and synchronized about what they're gonna do in this dance, as well as those two people that are holding the bamboo, then it won't be a tinikling dance. So there's a good example there. So writing the orchestrator plays a big role in making the stateful workflow and orchestration work properly to solve our problems. And so basically, the orchestrator is our friend, but it also is strict, because it needs to be deterministic. And this is an important characteristic of the orchestrator that new developers of serverless, especially working with durable functions, needs to know. And this means that we have to author our workflow in the orchestrator function in a deterministic way, which means that it expects the same result at the same time. And the entire function will be replayed. That workflow will be replayed. So this is an example of, as a visual illustration to the left, we see that there is a determined orchestrator that controls the workflow of all tasks or activities. And here also is another example where you don't have the orchestrator, which means that it can be separated or isolated tasks, and it doesn't have any control. For example, if this Azure function is provisioned in another logical virtual machine and that gets restarted, there might be you're gonna lose the state of that. So I think if you require stateful, I think I would believe that it is recommended to use the orchestrator or the durable functions. And then I mentioned something about orchestrator needing to be deterministic. So there are actually a list of documented code constraints for the orchestrator. And these are just a few of them, but there are actually more. So, for example, I'm talking in the .NET world right now. And these examples. So, for example, in the orchestrator, it's good. It's recommended not to write GUID or random numbers in your orchestrator, as well as configurations or blocking APIs, loops, for example. But what you can do instead is that you can use the method new GUID through the context, and then you can use your configuration you can pass your configuration through the activity functions. And then if you really need to repeat the process, don't use the loop in the orchestrator, but you can use the context method, create as new. And this syntax can be different language per language. So those are the constraints. And if you want to check the details, the rest of that, you can find it on Microsoft Docs or the link on this presentation. So I want to introduce you as well to the different patterns of durable functions, because that will help you as a developer or as an author of the workflow, which type of pattern that would help solve your specific business problem that you're trying to solve with serverless, of course. So there are actually 6 known patterns that's documented. We have the function chaining pattern, there's the fan out, fan in pattern, there's the async HTTP API pattern, the monitor pattern, we have the human interaction pattern, and the aggregator pattern. So the function chaining pattern looks like this. As it says, as you see here, it's like a chain. So it executes a sequence of functions or activity in a particular order. So which means that the output of the first function here, F1, is a required input, not really required, but it's needed as a sequence to the next function, and so on. And so forth. I can show you an example here in action. So, for example, we have 2 activities, things or tasks to do, and let's say that you have a blob trigger, like you uploaded an image to cloud blob storage. So that means it got triggered. This means the workflow started and the orchestrator got started its work, and then the activity 1 is scheduled. And then while activity 1 is doing its job, the orchestrator sleeps. And then activity 1 is done, the orchestrator wakes up, or activity 2 is doing its job and scheduled. The orchestrator sleeps again. Activity 2 is done, and then the orchestration is completed. But that's the first step, the first play, you call it. When it gets triggered again, it will replay. That's just like what I mentioned or shared earlier. So the orchestrator can be really a sleepyhead, like my dog in the morning, my Labradoodle dog in the morning. But it's good when the orchestrator is sleeping, because that means that you're not being charged for the other activities or the tasks that are not running. You're only charged for the instance that are actively running. And this is, as for specifically for durable functions, you are also not charged, especially on consumption model. You are not charged when you are waiting for an external event, because you can also wait for an external event, which will be, I'll show an example in one of the patterns. So it's good, especially if you want to take control of what activity or tasks that are being run by your workflow. So a practical example was a simple one that I have here. So we have an Azure Blob trigger, which kickstarts the orchestrator function or the orchestrator. And then that blob trigger can be saved. The first function chain is to send the message to Service Bus. Azure Service Bus is an enterprise messaging service in Azure where you can like save enterprise queue data, and then you can ask another client or application to grab it or get that, retrieve that data. So after that, it can also the blob gets you can create a function or activity to send a message to or call via Twilio API, and then you can also send a notification by email using SendGrid. So this example shows that Durable Functions gives us the flexibility to integrate it within Azure with its other services. At the same time, integrate it with external APIs like Twilio or SendGrid, which is commonly used today in other platforms. So I did actually have this a demo or project, mini project as a template. So it can be found on my GitHub, but currently it's that version is .NET Core. I know that .NET has recently upgraded to .NET 6 and 7 is coming. So I'm in the process of updating this template so that you can use it to get started, but you feel free to look at the code if you have .NET Core running in your environment. So the expected result would be like this. So I did get the message to the service bus queue. I got an SMS and then an email, and also a call via SendGrid. And then the next pattern is the fan out, fan in pattern, which is used to execute multiple functions or tasks in parallel. And then you want to wait for the result and then aggregate it when it's done. So this is how it looks in the code. This is in C#. So here we see a list of items that we're trying tasks that we want to work on, and then in the loop you have a work, and then you're gonna perform those tasks in parallel, and then you're gonna use the when all method to process the result, aggregate the result as one in this as well. And then the next one is the async HTTPI pattern, which pretty useful if you're trying to solve problems with long-running operations with external APIs. So one example of this is this simple one. I want to have a long-running to check if my website is available. And in this code snippet marked in blue, you see that I used the durable HTTP response, where I passed in my URL, my website, and then used the get method. And then I have a simple if condition, if else condition to check if what's the status of my website. And then I can further process that information or the content through the response farther through the code. And then the third pattern is the monitor pattern, in which you can actually do a recurring process in a workflow. Just like, for example, if you want to do a periodic job cleanup. So in this snippet, we have a while loop here that's checking if the status is completed, and then here also we have like an expiration time that checks on the time. And then here, as we notice here, when the orchestrator is waiting for that time, it's gonna like sleep for the next check. So it's gonna wait for that next event for the monitoring activity that it needs to do. And then the next one is human pattern interaction pattern. So this is useful if you have a business problem or a scenario where you want to like approve a human being to literally approve the process, just like the approval process. So here, an example in C#, so an approval workflow where you would have to create a durable timeout or a timer. And then you would have a condition here that your approval event, you're going to wait for that external event. And based on that event, whatever, when any of them comes first, a response from a human person, which can be a supervisor replying to an SMS or email, or if the timeout goes out. For example, here you have a timeout of 72 hours. What if that person that's supposed to approve are actually out in vacation? So you have that control to process further if no person or human being is doing that. And this one is also, the next pattern is the aggregator pattern or stateful entities, which is used for aggregating data, like event data from over a period of time. And that data can be coming from different resources, and then they can come anytime. And this is also a powerful pattern in durable functions that I won't dive deeper. But if you're interested to check it out, there's a documentation for durable entities, and this is widely used in .NET. I'm not sure if it's supported in all languages yet. And also, we have this, so I introduced you to the different patterns that we have, but we also have this flexibility to create any patterns that we want. I believe so myself, because of this feature of sub orchestrations in durable functions. So if you see here, this is just a very simple one. So if you really have a complex workflow, you can use sub orchestration feature of durable functions to do that. And I believe currently it's supported only in 3 languages, .NET, JavaScript, and Python. So this is how it looks in C#. So you're trying to like do a for each loop in your device, list of device IDs, and then in each of your device, you're doing something else. So that's the sub orchestration there. And if you're ready to develop Azure Functions after all the basics that you've learned and the patterns that you know, then you can actually, there are a lot of ways for you to learn. It's everywhere, it's free. And you just need to have time and dedication to learn. Learn by doing, that's what I believe. So you can develop using Azure Portal or your favorite IDE tools, basically for .NET or it's Visual Studio. But if you were like multi-language, open source and lightweight, there's VS Code. And then the most important one is that you can develop locally. So you would need to have Azure Functions core tools, the latest version, and some kind of Postman, like to do web request tests. And Storage Explorer, if you want to check how's your storage and instances for the workflow is doing, because it's logged as web jobs in Azure Storage. And then for coding durable functions, there are good things that you need to know. For example, for monitoring, I would recommend Application Insights to get integrated with that when it comes to deployment of making changes. So it's good with conscious versioning and making use of deployment slots. And then for security, Azure Key Vault is recommended to save your connection strings. And also Azure Storage Explorer if you're developing locally. And then error handling, usually if something goes bad, if you're in trouble, you code your workflow not so good. So you're gonna get this function failed exception. So in order to prevent that from happening, so these are my recommendations. So you can actually use durable timers to take control, for example, of the external events. And then you can also actually, if an activity fails, you can use the feature called call activity async with retry. And there you can set your own configuration, how often it will retry, what it will do when it retries. And of course, the typical standard try-catch block that we do in our code to prevent errors from breaking our applications. And then there's also durable functions monitor. So deployment, you can we have everything. You can do infrastructure as code. You can deploy your Azure Functions in Windows and Linux, and also GitHub and the normal pub XML way for publishing. And for learning resources, there are a lot, but these are some of my recommendations. So check out Azure Functions, the Microsoft Learn, and also there's another MVP in Netherlands, Mark Ducker, that has this school for Azure Functions for both beginners and high level, and it's free and it's open to community. So I recommend that as well. And then I always believe in learn by teaching, not just learn by doing, but also learn by teaching. So I also recommend being a mentor for Serverless Bit project, I was also a mentor myself. So those are good ways to learn and learn more about Azure Functions. So finally, I want to conclude that as a developer, I love Serverless because it helped me solve complex problems and help me build modern apps, and it makes me also productive. Thank you so much. And that's my labradoodle, by the way. So if you have questions or if you want a copy of my source code, feel free to connect. So I have my link tree there when you scan the QR code. Thank you so much.
Thank you, Jonah. Of course, I'm an amateur. I muted myself. That was great. Love the labradoodle. I gotta admit, I don't know a ton about Azure and Azure Functions. So this was kind of eye-opening to me, especially because I'd never even heard of the concept of a durable function. So I've got a bunch of questions for you about that. So because I want to dig into it a little more. So first of all, we talk about state, right? That orchestrator, is the orchestrator where the state is kept? Because you said it only goes to sleep and then wakes up. So is that where that would keep state across the different functions that are orchestrated by it, or how is the state managed in that?
I believe this state is in the entire durable functions package. I can call it, because of the durable task framework behind it. But
okay.
Yeah, so that's why it's important to. Thanks for the question, by the way. So that's why it's important to write the flow the proper way. Just like I had to share the constraints, because I think as a beginner it's important to know that the code constraints, like for example avoiding infinite loops in the orchestrator, because if you're a beginner and it's a consumption serverless model in the cloud, the one example consequences of that is you're calling lots of tasks, like calling an API, and it's running in an infinite loop, then that can cause consequences for that. But yeah, it's to answer the question, that's the durable task framework behind it in that for the durable one.
Okay. Yeah, and I'm guessing it would be easier in this kind of scenario to accidentally write an infinite loop, because you call a function that triggers an event that then calls, basically triggers the whole thing all over again.
It's like what do you call that? Inception, the movie Inception, yeah. Right? You have a workflow that replays, and then in the workflow you have the infinite loop, and that's what we're trying to avoid in that one. Right. So if you have a loop, if you need to repeat the process, you can do the call another activity async, or you can do that while loop in your activity task, like specific tasks that you're gonna work on, just like a normal application logic.
Yeah, and so I'm guessing the benefit here, besides actually maintaining state, is that it makes it easy for me to separate pieces of logic into very distinct kind of functions, but then the orchestrator then handles okay, I need to call these in a particular order, or I need to call these based on a workflow, or any number of things like you said, so I've been so used to writing just functions in that kind of, okay, I just call them within my code as needed, but never thought about like having an orchestrator to kind of manage all that.
Mhm.
Yeah. So that's the benefit really, like is I can then
Yes.
write very distinct functions that do very particular things, but then have all of them linked together in this orchestrator.
Yes. Without
Right.
losing the state, also the stateful workflow. So that's like the
Right.
one of the benefits, because you can use you can code serverless with normal Azure functions, just like what I shared. But if you really want the state of the task that you want not lose
Right.
it, that's so that's a good thing. It's a recommendation. But maybe some
Right.
use case, because we cannot do durable functions for everything. Just like solving problems with programming, sometimes you have to choose specific solutions. So that's why application patterns was a good way also to like identify which solves this. But one of my favorite is like, I think what could benefit this is the human interaction pattern, and also that approval workflow that sometimes you have to do that to automate a process, for example, or call an API.
And what would be the big drawback, say, to using, because you said you don't want to use these all the time. I mean, what is it, more of like a cost thing because of there's something different with how the durable function works that might cost more, or just because of complexity, or what would be your recommendation in terms of when I don't want to use a durable function?
I think it can be with the complexity also. I think so. I think it's important that you know what your workflow it's gonna be when and what you're trying to solve. So I think it can be it can be complex. Like if you like, for example, I showed sub orchestrations in an orchestration. So if you're trying to do that as a beginner, it can be complex, and when it gets complex, the debugging it can be tough as well. So it's
Yeah.
a powerful, but I'm not saying that it's not that durable functions that has that big witness it's the other way around. It is actually powerful. It's just that it doesn't it's not maybe perfect for all solutions, but certain solutions it's very powerful, because I know some users or business that have saved a lot of money because they're using Azure Functions or serverless in general.
Right. Yeah, I can imagine like it's basically use the simplest possible solution to solve the problem that you can. And if you don't need to have a durable functions framework going, go with a
Yes.
regular Azure serverless function or whatever. And then if you need to have this kind of workflow, then obviously this is super powerful. Excellent.
Yes.
All right. Yeah, that's awesome. I gotta I say, like it's really got my mind thinking about like how different ways I could structure some of the code I wrote and use something like this orchestrator to manage that. That's really cool. Thank you so much.
You're
So we
welcome. Let me
are.
know if you need help,
Yeah.
by the way. I can
Oh
help.
yeah, absolutely. Thank you.